Today we are going to be going over basically everything we need to do for web scraping. So what are requests, what's beautiful soup, some fun pandas functions, and then, oh, that should be, refresh that. And then a little bit about Selenium and Tor. So that's what we've got on the ticket today. If you want to go ahead and follow along, I'm going to just be live coding from the start, and I'll send out the answer key and like kind of the recap of all of this right after the call. So to go ahead and get started, if you want to go ahead to Google Colab and just go to any new notebook, pull that over here, and just one second. Great. So first things first, we're going to use a module called requests. So what request does is it goes through and it will pull up any web page for you and download the content of it. This is great for Python because it helps us take advantage of HTTP protocol and interface with the internet and have our scripts like actually go out and do something outside of just our computer. So this is great to use in everything. And the second one is going to be Beautiful Soup, and this one's a little bit wackier of a install. It's from BS4 import Beautiful Soup. I'm also going to go ahead and throw the pip install commands for anything if you're missing it up here on the top. So then once we have these two packages, we'll also go ahead and do our lovely pandas as always. And we're going to go ahead and get started with this. If you just want to go ahead and hit run on that, we'll start to see everything come in and import. So now the first thing that we're going to do, our problem statement here is going to be these American universities. We have a research project where we're preparing some text analytics data on how the history of American universities compares in Wikipedia entries. So to do that, we're going to go right over to here on Wikipedia Association of American Universities. We see all of these great institutions, and we want to see, all right, how does the history of Brandeis University compare to the history of, say, Iowa State University or Ohio State University? So what we're going to do with that then is get started and first of all, get our URL set. And you can just do that by pulling up any Wikipedia article, really. This is mainly just to kind of get a sense of what's going on here. The first thing we're going to cover is pandas df.read HTML, pd.read HTML. And if we plug in our URL here and hit play, we are going to get an array of all of the tables that are listed on that page. Now, this is great because it comes stock in pandas, and I actually found out about this today while I was researching for this, and it's pretty cool because you can just go through and pull up anything that you need instantly. But now, not only that, we want to go through and get our URL as well. So the great thing with request is that it follows the same protocol as an HTTP or curl request. So whenever I'm doing .get, I can do .put and .push, and I can put in my parameters, anything that I need. So it's similar to if you were using something like Postman. So this is fantastic on lots of levels. So we can go ahead and plug in our URL, which is again the same Wikipedia item. And then from there, that that variable R, that's going to house all of the content of that request return. So if you're familiar, if we're thinking back to how the internet works and how HTML transfers, that means that you're getting that raw HTML or XML file back into your machine and load it into that variable along with some other context. So what we're going to do is initialize a beautiful soup object. So what a beautiful soup object does is that it will go through and parse out that XML tree and say that, okay, let's use this in something that's a little bit more user-friendly and something that we can work with in Python. So with that, we're going to go through and get our content. You can also get a lot more from like the R variable containing the URL, stuff like response codes and different attributes, headers, and all of that good stuff, which is very useful if you're doing more intricate work with HTTP requests. And now this second parameter here, this is important because depending on the type of page that you're pulling, it might not always be an LXML file. It might be sometimes formatted a little bit wonky. So the general rule is to just use LXML, and that's just the protocol for it. Let's see if I can get the beautiful soup thing to show up with the parameters. Nope, all right. But, oh, there we go. So that's just kind of like the builder that we have there. If we hover over that, it should pop up. So that's going to be the next phase of this. So if we go ahead and hit run and then just print out, for example, soup and see what that contains, we see we get the entire HTML right over here. And now not only that, but we can actually go through and get even more verbose information about it. And we can do that by just going ahead and saying that, all right, let's find out the title of this soup. And the way that this is working here is actually pretty great. So if you remember back here, we have the URL that we're passing into the request.get. From request.get, that's going into a variable, which is our response. And then from there, we're just pulling out the content of that, which we're then parsing into something that can handle XML beautifully. That XML object is now what we're using, and that's what's called soup. So you can see a little bit about the docs right here on that as well, too. And that's what this is all containing right now. So the great thing about this now is that we can treat it like a regular Python object and just start to call things. So now if we hit print soup.title, it's going to just give me the title of this page. And now if we want to go ahead and say, let's find all of the H2 tags, for example, right? Also, if you're a little bit lost right now by the HTML, don't worry at all. Go on to, I'll send a link after this as well too, for W3 schools. HTML is more of a markup language and a document style than a programming language. So at least until you get to the DOMs part, but you can kind of get a good sense of things. It's not terribly difficult. It's basically XML. But yeah, sorry, going back to this, H2 is another tag that we can go through and find, and we can go ahead and get a list of all of these items. But now the main thing I want to do here is I want to get the links for all these pages, right? Because I want to go through here and I want to go and see, all right, what is actually in Boston University? I don't have all of these links, so that's in the table. So what I can do for that is I've got a reference table of all the universities that are American universities right now, right? I can also go through and find a specific tag. I'm curious for a little bit of audience participation here. Does anybody know the tags for links? I am trying to find my chat right now, but it's kind of buried under some monitor. So if somebody doesn't mind shouting out the answer.
Yeah, John and Ari said the A tag.
Yes, beautiful. Now, the interesting thing about the A tag, though, is that it's got one component missing, right? What component is that for every link?
John said href.
Yes, John knows his HTML. So what we will do is we will first go through and we're going to find all of the A tags. When we do that, as we were talking about, as John mentioned, we don't have all of them having href tags. And even these href tags, these hashtags, they're actually anchor links. So they just go to a different part of the navigation page. So now what we want to go through and do is that we just want these ones, right? The Wiki Ohio State University kind of links. those ones we can work with. We can get the relevant information we need for our project. So let's go ahead and make a new code cell and drop that down here. And what we'll do is get all of our links from there. So we will do links equals. Now I know you guys have done list comprehension, so I'm going to do this in two-step. The first step I'm going to do is href for I in so now does somebody want to, what do you call it, unmute real quick and tell me what this is going to do, or they think that it's going to do? Is there list comprehension? Now? All right, cool. So no worries. So basically what this is going to do is I'm going to go through each one of these elements in this array. I'm going to go through and see that, all right, is there an attribute? If you work with JSON, this is the same exact one for JSON and row columns. And I think all dictionary key lookups, if I'm not mistaken. Viren, if you want to fact check me on that, if you know. But basically what happens here is that we're able to just pull off any one of these tags that has the href in there. Now, when I run this, though, it's going to come back with an error, the key error, because not every single tag has href in it. Now, normally you'll probably expand this code out. I have been trying to train myself in list comprehension, so I've got all of it in here, and it's good practice to know it in list comprehension as well too. So I will just paste this portion right here. And all this is saying that if I, which is parsing through each element, has the attribute href, you're going to give me I href. Otherwise, you're going to give none for I in soup.findAll. So all that's saying is that check. If not, then go forward. So when we do that again, that runs. And let's go ahead and print out what are all of our links. Look at that. We have all of these gorgeous links. So now you can already see how this is incredibly useful, that if you can go through and find all of the links on a page, especially most pages that aren't as dense as Wikipedia, you are well a ways ahead of just figuring out whatever problem you need to tackle sooner. Now, after that, what we can go ahead and do is we want to get our, going back to that data frame we had, right? We want to get that table and line up the names of the universities with these links. So let's go ahead and check out our data frame again. So now, right now it's a list. It looks like the second one is the one with all of our institutions here. So what we can do is let's find out what columns that has, and we can get started off with that. So that's our target one that we need. So we can go ahead and say our list of schools can be defined as that. So again, all we're doing, df is a list, df2 is a data frame, and then this is the column header. And by getting the column header, we get all of, the entire column, and that column gets returned as a list, which is coming back into our list of schools. Now from there, if you notice, all of these formats, we can't use just the usual name. All of them are pretty close though. So what we could do is, also I completely understand that this is a very roundabout way of just taking a list of names and doing this manually, but this is to prove that you can do a lot of these things very quickly in Python. That being said, we can go ahead and do a little bit more list comprehension and just go ahead and replace all of those spaces with underscores. And then we're just going to create a list of all of the wiki schools that we need to go through and parse the data for. Now, when we go through all of that, let's go ahead and just check out what our list of formatted looks like. Look at that. That looks pretty similar to the other one, does it not? I think so. From there, we can go ahead and this is not the most efficient way of doing things, I know, but we can set up a nested for loop, which is going to iterate through all of our links and then our list of formatted schools. Check if the link is one that we need. And if it is, then it's going to place it into that list of wiki schools. So for IN links, go through, check if it's a list of formatted, blah, 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 go through, return as such. This line 7 can also be replaced with remove NA earlier as well too, or it can be more fault tolerant as such. It just depends on your personal preference. So now if we run this, we get the list of all the schools with wiki in front of them. So here we are. We have a decent amount completed right here. I'm going to say that I have some code right here. I want to go through and using some function, effectively return me a list of all of the histories of all of these places, or just returning the text or like headers or whatnot from each of these pages. So if I was to do that, or just return any attribute from these pages, how would you go on and do that? So take a few minutes. I'll throw you guys into breakout rooms for like 5 minutes. See if you can work on a function that can do that. Let me go ahead and share this workbook with you guys. And that way you can at least see what is going on and make a copy of it if you'd like. And we'll get going from there. If not, that's really cool. Let's go through and write it then, right? All right. So what we're going to start off with is def some func site classic start, and then oh, the loops beforehand. Right here. Is this all coming through shared as well, by the way? On the collab doc that I shared with everyone? If I could get a yes or no from someone. Awesome. Okay, cool. Thank you. So what we'll do is we'll go through here. And now, for example, let's just say if we want to do sentiment analysis on it, right? That like, if we want to just compare rivalries and see that our schools with big rivalries like us and Michigan having a generally higher sentiment score in all of our writing and language, or, you know, is it just generally like, is there no correlation? So to get started with that, we'd have to pull all of the text off of the site. So in order to do that, first things first, we're going to do r equals requests dot get site. Now remember, we're assuming we're passing in a URL here. From here, what we'll go ahead and do is we'll load it up again into Beautiful Soup. So remember, this is pretty standard content from earlier. And from there, we want, can anyone tell me what tag we're looking for if we just want to get all text? All right, it is a p tag. Oh, thank you, John. So the p tag stands for paragraph. So one thing about basically HTML that's great, I love calling it a Microsoft Word document just because Microsoft Word documents have a similar structure with how they do their outlines. So, or even Google Docs with H1, H2, H3, H4, H5, H6, blah, blah, blah. it's the same exact document structure. So it's nice to kind of compare it to that and get a better idea. But yeah. So, and in that, all we want to do is we want to go through and pull out all the text, right? We don't care as much about the tags themselves or what are their attributes in CSS classes. So what we'll go through is just go through each one. Remember, X is just the individual tag objects. It's not actually, the text itself. So we have to go through and pull that out. Beautiful Soup is also great for, it's a very lightweight package. So it's great for when you've got HTML content that's read in. Oftentimes, if you're pulling RSS feeds or anything as such, it's great to go through and parse XML. So I definitely recommend it for anything that you're doing. And then after that, all we want to do is return X. So now what we can do is up here, I want to go ahead and say list of texts is equal to a blank list for a quick second. And then I will say list of text dot. And great thing about Jupyter that I love, I don't have to have everything ordered. Run that. And then now if I run this, what do you guys think is going to happen? Do you think I'm going to get it to go through completely correctly, or does anybody see any errors with this right now? And this is one I'll open up to Viren and eBoard and Libby and Ali and Cameron and all of you guys too, because.
Are some of these links internal? Like, would that be an issue?
Could you speak up a little bit?
Yeah, like some of these links don't start with like the whole like HTTP colon and whatnot. It's like internal links to Wikipedia.
Absolutely. So that is one of the only annoying things I don't like about Beautiful Soup is how it handles internal links. And I wish that they could fix, like, there's nothing to fix, but we can dream. So we'll go ahead and copy that original link. And then when we come back here, rather than going through and making our life miserable with lots of things, what we can do is just grab that. And just in case, cap it off in a string. And sometimes things get buggy with HTTPS. See, now I forgot I was running this over like 30 universities or 64 universities. So it's kind of like going through and hitting each one of those pages, pulling all of the text from it, and then returning it all into a list, which is pretty fun. I think you guys can kind of get to see like a little bit of how powerful some of these tools are. And this is just the beginning of it as well too. Now, one thing you do have to be careful for is looking at robots.txt files. And just seeing that if some of them can be web scraped. Please, for the love of God, do not scrape any academic sources or anything that is copyrighted. The government will come down on you like the hand of God. If you're interested in more about that, there's a great history about it with WikiLeaks, and one of the original co-founders of it. He scraped JSTOR, and federal prosecutors came down on him like a hammer. And yeah, great stuff to look into, but also, yeah. And I think we might have just hit a reason for that when we're going through in bulk scraping this. We might have just gotten stopped by that. Yes, George, you absolutely can. Most of these sites you can scrape and it's not going to be an issue. It's mainly because also you're loading it all on your end. Just try not to consistently ping. That's the big thing, actually, George, that you're saying is the huge issue with scraping. It's the constant request and pinging. Now, a big reason why I would have gone a message like this for this and not the upper ones is because I tried to go through and hit 17 pages instantaneously. That's not going to be good. But also, one thing that can help with that is a user agent and headers. So if you remember from earlier, we had some headers being passed along, or sorry, we didn't have any headers being passed along. Let's throw this in right here. So what these headers are, it's just going to kind of say that like this is what the CSS styles are, and it's going to trick the website into thinking that you're an actual browser coming in. So it's, yeah, it's pretty cool. And just in order to ensure that that gets plugged in, let's go up here to right here. Yeah, so then that's how you kind of set everything up, and then that should go ahead and run and return. That's kind of the bulk of what's going on here. So just up to that point, are there any questions? No? Okay, great. Let me pop open then. Now, for example, if we're doing a lot of work in web scraping, and if you're going through and saying that, all right, I can go through, I can interact with this web page, I can pull the XML document, I can follow these links, I can do that. That's great. Now, that does a lot, but there's also one other aspect that we're missing. How do we automate our browser? How do we go through and sit here and like just make everyone think that we're an actual human and pass Turing test on websites? Now, that's where this very fun tool comes in called Selenium. And it's this other tool as well that I love called Catalan Screen Recorder. So Catalan Screen Recorder is an extension that looks a little something like this. So what it does, Selenium is a test suite generation software. It's a pain in the ass to install, but once you get it installed, it will work like a charm. I highly recommend do not do it on WSL. Run it on stock Windows, stock Unix. Just run it on something stock. You're going to run into a lot of errors otherwise. But the nice thing is with Catalan Screen Recorder, what I can do, let's go ahead and do a new test case. This is a Chrome extension, by the way. I'll send out the link for this as well, too, in the PowerPoint. I can go ahead, create a new test case, record, click here, type in my first name, 3, and then submit. Now, if I go back here, look at that. I now have every single action that I did, as well as this fantastic XPath thing, which the greatest thing about Selenium is that you can go through and target things by XPath, and it is like the unique idea of an HTML element, so it will never go away. But I can take all of this, and I can go ahead and export it into Python. Now, all of this code is already done for me, so if I take this and copy this into Python and I've got Selenium running, I can do all of this instantly. But yeah, that's something that we're going to cover a little bit later on, as well as using stuff like proxies and Tor and all those kind of things with web scraping and showing off how you can do some of that cooler stuff as well too. Yeah, I think there was a question in chat I just got the notification for. Yeah, XPath is goated. Awesome. That kind of wraps everything up on my end. Does anybody have any questions? if not, thank you. Feel free to stick around and chat. I appreciate you guys coming out. Hopefully you learned something. And yeah.